we are back to talk about some geometric series here today. This is our fourth and final lesson of Unit 7, and we are going to talk about series and what to do with them. Our goals are to be able to find the sum of a geometric series, as well as to be able to find specific terms in that series. A series, again, remember, is simply adding up the terms in a sequence. Just like arithmetic, geometric is the same thing. So if I have a sequence of 1, 2, 4, 8, 16, the geometric series would be 1 plus 2 plus 4 plus 8 plus 16, and so on, okay? So again, it doesn't matter what your R is or anything like that. You're simply taking the sequence and you're adding the terms to make the series. S sub n, again, is the sum of the first n terms of the series. So if we're given this series here, 1 plus 3 plus 9, etc., and I want to find S sub 4, I would be adding the first 4 terms, and I would get 40 for that. This should look familiar because this is very much the same as arithmetic series, that we're adding the terms together. Formula is a little different, though. And again, we have 2 of them depending on what pieces we know. The first formula, S sub n equals A1, etc. Or we've got one where we maybe don't know some information, we can use A sub 1 there, okay? So they're very, very similar. They're basically the same thing, and we can use either formula. In the book Roots, the author Alex Haley traced his family history back many generations to the time one of his ancestors was brought to America from Africa. If you could trace your family back for 15 generations, starting with your parents, how many ancestors would there be? Okay, this is kind of interesting here. So let's think about this here. You are a generation, right? And there's one of you. And you're going to trace your family back 15 generations. How many people would we be talking about? Well, if there's one of you, I'm sorry, it says starting with your parents. There's 2 in your first term. Each of your parents had 2 parents, right? So now that's 4 people. Plus your parents makes 6 ancestors that you have. Each of those grandparents also had 2 parents, so that's 8, right? So think about this. Each time you're multiplying by 2 people because each of those people in that generation had 2 parents that were their ancestors. And we can kind of go back and back and back. Now we could just keep going till we get to 15. But let's try using this formula, okay? Because then we'd have to also add all of those terms together. Let's try this out. So we've got our first term is 2. 1 minus, now what's our r here? We're multiplying by 2 each time, right? Our r is 2 to the nth power, which is 15. And I guess I could change this then, this n over here, to also be 15. So let's figure this out. We're going to start with 2. 1 minus 2 to the 15th power. So 2 to the power of 15 is 32,768. And then on the bottom, 1 minus 2 is negative 1. Okay, let's keep going with this. On the top, we have negative 32,767, which we're then going to multiply by 2. And we get negative 65534 over negative 1, of course, is positive 65,534 people. That is a lot of ancestors. So going back 15 generations, you're related to over 65,500 people who have lived. That is staggering to think about. That's a lot of people that you have a genetic tie to, okay? Find the first sum of the geometric series in which A1 equals 15,625, AN equals -5, and R equals -1/5. I think AN is supposed to be, oh no, that's right, it's the sum. It should be SN. No, it shouldn't. Your last term is -5. Wow, I'm having trouble thinking through all of this today, obviously. So we want to find the sum. Okay, so let's start with that. SN. We know that our first term is 15,625 minus, and our AN term is -5 times R, which is -1/5, over 1 minus R, which is -1/5. So now I've kind of put everything into this formula. And then I want to just evaluate it. So let's start with the top, and we're going to take -5 times -1/5, which is +1. On the bottom, I'm also going to change that to 1 plus 1/5 because minus and negative is adding, okay? 15,625 minus 1 is 15,624. Divided by 1 plus 1/5 is 1 1/5, or 6/5. Now again, here's where your calculator comes in real handy, because you want to take 15,624 divided by, and then just use that fraction button, 6ABC5, and you get 13,020. That is the sum of the first however many terms, okay? That's a little easier than trying to find all the terms, then add them all up, especially because we don't know quite a few of them. Now, we want to go back to sigma notation because we can use this for geometric terms as well, okay? And it's the same idea as before, except that you're just evaluating probably a slightly different formula, which is going to have some exponents in it, okay? So here we've got 6 terms, and we're going to evaluate by adding them all together. So let's start with our first term. So we're going to plug 1, in for n. I'm going to take 5 times 2 to the 1 minus 1 power. Well, 2 to the 0 power is 1 times 5 is 5. Now I'm going to do the same thing, but this time I'm going to do 2 minus 1. 2 minus 1 is 1. 2 to the power of 1 is 2 times 5 is 10. Then I'm going to do 3 minus 1, which is 2. 2 to the power of 2 is 4 times 5 is 20. I'm going to do the same thing for n equals 4. So that's 3, and I get 40. And then I'm going to do 5. So 5 minus 1 is 4. And I get 80. And then 6. 6 minus 1 is 5. 2 to the 5th power is 32. Times 5 is 160. And I'm done because I have my 6 terms. Okay? Now remember, I also have to add all of these up. I'm going to add 5 plus 10 plus 20 plus 40 plus 80 plus 160, and I am going to get, 315. There we go. So this equals 315. So I've just evaluated. I'm just, remember, plugging in all of my n values from 1 to 6, and then adding those numbers that I get all together. I can also find some different things. So this is telling me to find the first term for the geometric series, in which the 8th term, or the sum of the 8 terms, is 39,360, and R is 3. So I'm just going to plug in what I know. Okay? So I know that the sum of all the terms is this. I know my first term is what I need to find. I know my R is 3, and I know my N again is 8. And I'm just going to solve. I'm going to take 39 360. And I have A1 times 1 minus 3 to the 8th power is what? 1 minus 3 to the power of 8, negative 6560 over negative 2. I'm going to multiply the negative 2 by the 39,360 to get that out of the way. Get negative 78,720 equals A1 times negative 6560. Now I'm going to divide the 78,720 by the 6560, and I get 12. So my first term of this series is 12. Again, working with what you know, just plug it into the formula, the different pieces that you have, and then solve for whatever you don't know and you need to find. So hopefully you're feeling confident about finding the sum of any geometric series, as well as being able to find specific terms. A lot of times we're looking for the first term or the last term, but you could find anything really, and being able to evaluate a geometric series. This has been brought to you by Conalonzo Inc. We are here to help you with your math, so let us know if there's anything that you need. Take care and stay well.